The gravitational field problems, we're all looking at what happens on the surface of the Earth. So this is going to be the gravitational force of the Earth on a small test object placed on its surface, divided by the radius squared, so that's the force exerted, divided by that mass of the small test object, so we can just look at the influence of the Earth at its surface. Okay, now for all three problems, we're going to essentially start with the setup here. Gravitational field is GME over r squared. So for the first one here, we have the mass of the Earth is 1/3 of its original value, and the radius is reduced by half. Because that is being squared, you must put it in parentheses. So we are left with 1/3 GM all over 1/4 r squared. You have a fraction, flip the bottom of the fraction and multiply by the top. You then have 4/3 GM over r squared, or 4/3 of the original gravitational field. Okay, for number 4, if they're asking for the radius here, we want to rearrange that equation we started out with. So 5g is equal to gm over r squared. I'm going to rewrite this as r squared times g equals gm, and then rewrite it again. R squared is equal to gm over g, and then take the square root. R is equal to radical gm over g. Now the reason I do this is because if we're seeing what happens to the radius of the Earth, this is much easier to deal with the proportional reasoning. So in this case, all right, we see that the gravitational field is half the original gravitational field, and then the mass is 4 times the original. Make the whole thing is square rooted. So 4 over 1/2 is going to be the square root of 8 times gm over g. The square root of 8 is going to be 2 radical 2 times radical gm over g. So the radius of the Earth is going to be 2 radical 2 times the size of the original. Now going down to the last one here, again, we'll start out with the gravitational field. And since we are looking to find out what happens to the mass, I'm going to rearrange this to equal the mass, so then our proportions are a little bit easier to deal with. So m is going to be r squared times little g over big G. And then when we look at this, we have twice the gravitational field and 1/4 the radius of the Earth. So this is going to be 1/16 r squared times 2g over capital G, or 1/8 r squared g over g. All right, and there you have your answer. So